Hello everyone and welcome to this ActiveHDL tutorial. My name is Chantel, and for this tutorial I'm going to be covering FSM coverage. So ActiveHDL has a lot of coverage analysis options, one of the options being code coverage. And within the set of code coverage types is FSM coverage. And this type of coverage allows you to identify the states your FSM has visited, as well as the transitions it didn't evaluate. So for this tutorial, I'm going to be using the sample design called data path, and I'm going to be using the state machine control FSM. And to find this, you're just going to go to help, open example, and it will be located under VHDL designs. And before we can get to simulating, we're going to need to make sure that code coverage is enabled. So head on over to design, go to settings, and then in coverage and profiler, make sure that ACDB coverage is selected, and also make sure that FSM is checked as well. Hit apply, then OK. And then from there, we're going to compile all to apply those settings. All right, we could see that it's a success, and you could see that coverage has been enabled. And now, before we go on to simulate the test bench to get our coverage report, I'm going to have to talk to you guys about Pragmas. So, in ActiveHDL, ActiveHDL does not automatically recognize the finite state machines from code. And so, in order for ActiveHDL to recognize the FSM and for us to be able to obtain the coverage statistics, we would have to define the FSM components and concepts. And that's where Pragmas come in. They help define the following FSM components and concepts, such as states, transitions, and sequences. And as you can see here, the sample design has already given us some Pragmas for the control FSM. And there are actually two types of Pragmas that ActiveHDL can use. One of them is the SystemVerilog LRM, and these Pragmas can only be placed within the scope of a SystemVerilog module. And the second one that this design is using is the Aldec proprietary Pragmas. They can be applied to both SystemVerilog and VHDL code. And additionally, Aldec proprietary Pragmas has additional functionality that's not provided by SystemVerilog LRM. And that includes things such as defining illegal or ignored states, transitions, and sequences. And so in order to be able to use these Pragmas, you're going to need a comment delimiter, which would be double backslashes for SystemVerilog, followed by the required keywords, Aldec enum, and then the enumerator identifier. And then from there, you're going to need the Pragma name, and assign the Pragma name the value. As you can see here in this sample design, there are already Pragmas used for current, initial state, states, and transitions. Just real quick to take a look at the ActiveHDL user manual, you can see that there's actually a lot more Pragma names that you can use for the ignored and illegal states, transitions, and sequences. You can see that there's also the Pragma name for the sequence itself. And now that we know about the Pragmas, now we can go on to simulating our top-level test bench. It's going to be this file right here, and make sure that it is the top level. And now we're going to initialize the simulation, and now we're going to run it. Now we can see that the simulation has finished. We can generate our report. Head on over to simulation, go to ACDB coverage, and we're going to generate our report. I'm just leaving FSM as the only one checked off, and from there I'm going to go to the FSM coverage options and I'm going to uncheck this, but I will check this later on. This is for additional debugging information, and in the command line it would be passed as the argument -FSM debug. So now I'm going to hit generate. We could see that the report has been completed. Now we're going to open the report. And now you can see here, this is the cumulative summary. If I had more than one coverage enabled, I'm just going to go straight to the FSM coverage. And now we can see in the summary page, we can see the final coverage result. That is an accumulation of the percentage ratio of states and transitions. We can see that states is 100% hit rate, but the transitions is not. And now if we go to the FSM coverage detail report right here, I'm going to expand this more and more. You can see that there's two columns. We have the left column for the FSM that shows the name of the FSM itself, as well as the component types, which are states, transitions, and sequences if there was any. And within each component type, there's all the bin values labeled. We could see that in states, all of these bin values have been hit at least once. But as we could see in transitions, we can see that 3 out of the 14 have not been hit. And that's why the ratio of transitions covered versus the total number of transitions is 11 out of 14. And if you click on right here, you could scroll down through the code and you could see where it starts, where it's not covered. And you could see this is where the Pragmas are inside of the source file. But now I'm going to close this and I'm going to end this simulation and I'm going to create a new test bench. I'm going to go back to the control FSM right here. And now with the FSM option, I'm going to generate a new test bench. I'll be using strategy 2 for this and I'll generate a new test bench from there. There we go. Now I'm going to compile all to make sure that the coverage settings are applied. And now I'm going to use the macro script generated from the test bench generation as well. I'm going to make sure to comment these out. And now I am going to initialize simulation once again. And I'm going to do that by executing this script right here. Yep. Alrighty, we can see that the simulation has finished, and now we can generate another ACDB coverage report, but this time I'm going to check off this box so we could see the additional debugging information generated. Now we'll see that it's generated. Now we'll go back to our ACDB coverage HTML file, open that up, and now we can see that our summary shows that all of these states, transitions, and even sequences have been successfully hit in this specific test bench that we created. As you can see here now inside of the FSM coverage detail report, we can see an additional column that says extra info. You can see for the FSM, the source file and the line number of the signal or variable that denotes the state register declaration. And you can also see in the list of states that there's additional info for the values of the defined states. And that concludes this tutorial on FSM coverage. I hope you guys find this helpful, and thank you guys for watching.